So let's talk about hypothesis testing and what exactly it is. Let's look at an example of a coin. Coins in general, their p-value, their probability of getting ahead is 50%. Now, I want a trick coin. I would like to have a coin where I can get heads more often so I can win bets. So I go to a store, and the store says I have a coin that comes up heads 56% of the time. Awesome. They tested it 300 times and got this number. Now the question is that right? That is this coin really a trick coin? I mean, it looks just like a penny. So if I had a regular coin, I have to ask myself, could a regular coin get heads 56% of the time if tossed 300 times? If that could happen, then that trick coin probably is not a trick at all. So I'm going to test this out. I'm going to assume the status quo, which is I'm going to assume that trick coin is just a regular old coin that has a 50% chance of getting heads. And then I'm going to test if it's possible that it actually could get heads more often. That is my alternative hypothesis. This right here, the status quo, is my null hypothesis. So to test this alternative hypothesis, I need, of course, a normal curve. So first, I check conditions. We'll talk about that later. And once I have all the conditions set, knowing that I'm okay to do a normal curve, I'm going to draw one up. Now my center is at 0.5 because, as I said, I'm assuming it is the status quo. And my standard error here, remember, this equation right here, I used to find it. So then I can finish labeling up my normal curve. And off we go. I want to find the probability that I get 56% heads. That was my p-hat, what I found with 300 tosses. So I make my normal curve and fill that in, and this is my probability right here of more than 56%, and we call that the p-value. So to find the p-value, I'm going to use my norm CDF. I plug it into the calculator and boom, I find out that the probability of getting 56% heads is 2.3%. Now, is that significantly small? My results show me that there is a 2.3% chance of getting 56% heads when tossing a regular coin. Because remember, I'm using that HO, my null hypothesis. I'm assuming the coin has a 50% chance of getting heads. Now, this seems kind of small, like it's almost amazing that it happened. So I want to know, is it so amazing that it happened? Is it so significantly small that it couldn't have happened and perhaps it's actually not a fair coin? Now, how can I say what is surprising and what's not? I don't know what's surprising, but I'm just going to say that, and most scientists say this, the standard for surprising for significance is 5%. If something happens that there was a less than 5% chance of happening, then we are super, super surprised. When the p-value is smaller than 5%, we are so surprised that we actually reject HO. That means I throw away the idea that it's a normal coin, and I say this really is a trick coin, and I'm going to spend 10 bucks buying it. So with hypothesis testing in general, if we look at the probability of something happening and it actually ends up being bigger than 5%, we say, you know what, there's a chance it could happen, so the status quo must remain. We're going to retain HO. But if we find out that our p-value is less than 5%, that is the probability of it happening is super small, significantly small, then we are going to reject HO and take on this new idea that yes, there truly is a trick coin.